proofs. Again, same concept. You're not going to have to write a proof and recall everything beginning to end. You're just going to have to choose from either a drop down of statements or a drop down of reasons, or possibly both. But like I said, it's going to have some overlap with what we did in segments. So I figured we'd just go ahead and get this done real quick, and then you can practice the IXL. So angle relationships. Oh, shoot, didn't do the one. All right, so what statement can we make from that figure? My board's messed up, so I'm not going to do as much on the board. What can we make? What statement? Statement.
Ooh, that BAC is congruent to CA.
Can you? Somebody would do that. How do you know they're congruent? Tell you anything that says they're congruent?
Because CA is bisecting.
Whoa, how do you know it's bisecting? So here's your main part of this bell work. Don't assume anything from a picture. If they do not give you information that tells you something like the angles are equal or the line segments are equal, I didn't tell you. Now I drew it where it kind of looks like it, but that, I mean, this angle might be 30 degrees and this might be 29.9999. That's not congruent. So you have to be given information in order to make that conclusion.
So what's this, like a trick question?
Is adjacent to CA.
So you could say they're adjacent if you wanted to. That's not really going to help you in a proof. But using that information, what could you say that would help you in a proof? What was the last thing we learned, or the big thing we learned in line segments yesterday? We had already kind of done substitution. So what was the main thing we learned yesterday? Number one thing from yesterday, your number one takeaway. One person. Yeah, little plus little is big, remember? So what did we call it? We learned the actual name for it. We learned it before, but what's the actual name for it that we would use in a proof? The number one takeaway from yesterday. Look it up. It's in your note. I mean, it's in your book pages. So find it in your book pages because you've got to have this.
Segment addition.
It is segment addition. Good. So the segment addition theorem we learned said, actually it might have been a postulate, but my board is so off. It said if I have a line segment, oh boy, that's a horrible line segment. But if I have a line segment, and if I have A and then C, oh my goodness, what do you call it? And then B, that first one is supposed to be an A, not a delta. So it would say AB, I'm not even gonna write this part. I guess I could type, but AB plus BC equals AC. That is the number one thing you should have gotten out of yesterday. And more importantly, I guess from yesterday, because you should already know that part, that's the segment addition or line segment addition. I think it was postulate. You just wrote segment addition. You'll probably be choosing most of the time, so you just pick the right thing. Segment addition. AB plus BC equals AC. So then we talked about substitution being very important. We talked about the fact that the midpoint theorem meant that really the only reason they would tell you something is a midpoint is if you were going to say one segment equal, the little segment equals the other little segment. That's the only reason they would tell you something's a midpoint. What else did we, we emphasized, I already said we emphasized substitution. Definition of congruence came up quite a few times. There was that other thing called the transitive property. Make this note real quick. I don't know if I said it in this class. If you are thinking substitution should be used, but you don't see substitution listed in the dropdown, look for that transitive property. Transitive property is based on substitution, so sometimes they'll use that instead of substitution. So if you don't see substitution and you're thinking substitution is the right answer, see if transitive property is there. Transitive property says if A equals B, still that one. So if A equals B and B equals C, then we can say A equals C. That's the transitive property. Well, it's kind of like substitution. Like I said, well, if you know that A equals B, you could substitute in for B A, and you would get A equals C. Again, if you're not seeing substitution as an option, it was that works. Transitive property. That's what that is. It's basically substitution. All right. So what's the only statement we can make then from these angles? BAC, CAD. What's the only statement? Or BAD.
BAC plus CAD makes up BAD.
Man, that didn't help at all.
You did.
So it's the exact same thing, and again, we'll learn the name of it, but I'm assuming it's going to be the angle addition theorem. But it would be that BAC, oh, and then I have to write angle, plus angle CAD is congruent to or equals, if we're talking about measures, the big angle, angle BAD. So it's the same exact thing we learned in line segments, only we're dealing with little angle plus little angle equals big angle, instead of little segment plus little segment equals big segment. I figured we just go ahead and kind of sort of rush through this lesson, and then you can practice IXLs on both line segment proofs and angle proofs. Any questions on any of that or anything we did last class?
When did you?
Anybody who was not here last class? So I'll finish recording it. Like I said, it got cut off. I'm going to finish recording it. So those of you that we didn't finish the last proof, I'm just going to record that instead of going over one thing at the beginning of this class and wasting the time on that. I'll just record it. You can go back and watch it to finish it off if you even need to. If you're getting proofs, you don't really need to go back and watch it.
Mr. Gill.
Yup.
Teach Judge, when did you tell us about these theorems? Like just a theorem thing.
Well, some of them you're just supposed to know. You're supposed to have known them from past years of math. That's why I say teaching proofs is like teaching you, either reteaching you everything you've ever learned in math, or expecting you to be able to recall by memory everything you've ever learned in math. So that's why I say it's very challenging. It's challenging to teach because I don't have time to go back and reteach everything you're supposed to learn. And it's, again, a lot of it's just logic-based processing. If you struggle with the logic part, then I can't really teach you logic. I can teach you hints to try to help you, but all right. So yeah, just like we said, protractor postulate, kind of like the ruler postulate, just says that an angle has a measure in degrees. We can assign a number of degrees to an angle. They actually just give you all the theorems. I like this, or all the postulates and theorems. Angle addition is the one we just did. So that one's definitely, if you're dealing with angles, that's going to be used a lot. If you see angles involved, especially if it looked like that figure where there's a big outside angle and two smaller angles that make up that angle, almost guaranteed that's going to get used. Supplement and complement.
They're basically just what we have learned about.
It has to do with 180 degrees. This is specifically, though, for a linear pair. So what's a linear pair mean? Let's review that, because that was one thing we struggled with. All right, that's fine.
They're on the same line.
Yeah, so a linear pair is what we talked about. If I have a line, how many degrees in that line? 180 degrees in a line, right? So this is all review, so I'm just going to go through it fast. So again, 180 degrees in that line, that's 180 degrees. If I split that line, or that angle, I'm sorry, how many degrees in a straight angle is really what I should say. If I split that straight angle into two smaller angles, there's still 180 degrees in that straight angle. It's just now it's made up of two other angles. So we'll say angle 1 and angle 2. Well, if I add those two angles together, they should add up to 180 degrees. They have to add up to that original straight angle. So that's what this one is saying, the supplement theorem. They're supplementary, they add up to 180 if they are a linear pair. So anytime you have a straight line, we've done this before, like nothing, this is not new. We just didn't specifically have to use the name of the theorem that has been proven to be true. Now we will when we do proofs. Complementary would be if I gave you a right angle, apparently you're going to prove that in a little while. If I gave you a right angle and I told you it's a right angle, so we know that's 90 degrees. Well, now if I split that into two angles, those two angles have to add up to 90 degrees. So that would be the complement. So just remember, supplement has to do with a straight angle, which is just a straight line. Complement has to do with a 90-degree angle, and then splitting that into two angles. All right, so let's look at angle addition. I'm assuming we're going to prove this out. All right. Huh. They actually didn't give us any. I think we're just solving this. I don't see any. It's oh, okay. So I guess, yeah. So they are telling us angle, measure of angle 1, measure of, actually the first one in this is not given. They don't really have a given statement. They kind of give us information. This is a little bit of a different proof. Oh, I didn't mean to do that. Yeah, they start immediately with that. And then they say that. So those are kind of given statements, but this is a little bit of a different proof. It may not be that 2-column proof we did before. There are other types of proofs. There's a flow chart proof and a paragraph proof. We didn't do a whole lot with those. Those are just more what's the logic behind getting from the beginning to the end. In a flow chart proof, or I'm sorry, in a 2-column proof, they would give you a given statement. This kind of looks like 2-column proof, but they're doing it a little different. So what was that?
Second one is probably substitution.
Yep, absolutely substitution. So really quickly, so angle addition. Again, this is more than 2 angles adding up to be a big angle, but it's the same concept. Angle 1 plus angle 2 plus angle 3 has to equal the big angle, ABC. So that's still angle addition. So that's still angle addition. Now, just like Lucas was saying, I'm still sticking with it. Substitution is going to be a go-to reason. You have any kind of proof about line segments and angles. You've got a bunch of stuff that equals, like, this equals that and this equals that. You're going to use substitution in most proofs. So let me get it back to where I want it. There we go. So I am taking angle 1 and substituting it.
Oh my God, it's such a good circle, but not where it should be.
No, but we can fix that.
Third one is probably combining.
There.
If that was off too.
So there we go. I'm just taking those 2 angles there and I'm replacing them with the values. I don't know if substitution would actually, I mean, I guess we have to use substitution, I guess.
Or it could be given.
Because I guess they're saying this is the given information, that right there, the fact that it's a right angle. So I guess, yeah. So still substitution. We're replacing angle 1 and angle 3. I'm sorry, angle 1 and angle 2. We're replacing them with their value. We're substituting in their value. Let me just make sure that's what they did or they called it. Two, 3. Yeah, substitution. And then from there, the rest of it, they're just using all the
Properties.
yeah, they're just doing the math basically. They're calling it substitution in some places, so I don't know.
Third one is combining lines.
Why are they calling? I don't know why. I'll be honest, I don't know why they're calling this line. They also call this substitution. I would have just said in another proof they said that's addition. So I don't understand why now they're calling it substitution. Yeah, it's, well, in another proof, they literally just said addition. Like we did a proof where they said, I think it was X plus X, and they made it 2X, and they called the reason addition. Now they're calling the reason something else. So I'm not gonna have anything where you have to worry about figuring out what reasoning there
Or
is
like
behind
that.
combining numbers.
Or like
There
go.
won't be anything like that, so
I think.
don't worry about that. This would, now you do need to know this next one. What is the next one? We've had this one before. What is that? That's, we said, anytime you're subtracting or adding or multiplying or dividing the same thing on both sides, we would say that's like subtraction property or addition property of equality. Subtraction property of equality. That one you will see. I don't know that I'll put it on my quiz. I may not, but you will definitely see that, I would guess, on the district quiz, which again is 20% of your semester grade. That's one you need to
Is
know.
the last one also stuff?
Pretty easy one to figure out, even if you forget exactly what it's called. If you're choosing from a drop down and you see all of a sudden they just subtracted the same number on both sides, I'm hoping you can pick subtraction property. And they call this last one substitution instead of just doing the math, so I don't understand.
Addition.
Well, they call it substitution again. I don't understand why they're calling it substitution. I would not call it substitution. Anyway, I'm mainly concerned about the first couple, angle addition and then substitution. If you understand those first two steps, I'm fine with that. So let me do, since my board is all messed up, let me do it from over here.
I think it got me. It stayed messed up if you stop in the middle of it.
Maybe, yeah, I did,
Maybe
so
you're taking too long. Okay,
we'll see if I need to try to do it
I just
again. I
got
will.
delayed.
Boy, they're using a lot more numbers in this one than they did in the other one. All right, so
That's easy.
yeah, we're not gonna do that one. I want to get to the one where we're gonna prove the angle addition theorem. I think they said we were gonna prove. Enter your answers. Where's the check? Let's skip that for now. You're gonna practice IXL. Okay, here we go. Let's prove these. These are the ones I want to prove.
What's that?
All right, so we did these also when we did line segments. We said if we have the same angle, that's the reflexive. So angle 1 equals angle 1 or is congruent to angle 1. We said if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. Again, all the same properties. We just have them for angles. And then transitive was the one I said, well, that's really just substitution. If you don't see substitution, then there's pretty good chance it's a transitive property. They're the same exact thing. I don't even know why we have both. Like, I don't know why we use this instead of just keeping substitution. It's the same exact thing. I'm sure there's a reason. Well, but again, this math was created a long time ago by,
You should know.
I don't think you can know, why did they name substitution substitution? Why is that word called substitution?
That's why you're teacher. You're supposed to know.
I don't know. I didn't come up with a
Logic,
definition
isn't
of the
it?
word.
It's logic.
Oh man, they're doing paragraph proofs. I hate paragraph proofs. Or actually, maybe this isn't a proof. Maybe they're just walking us through.
It's more writing than solving.
All right, let's just go through these real fast then. So again, if we are given what? What are we given? What's the given statement? Yeah, so we're given this, right? I mean, right there it says given. So this is all you'd be writing in. That means congruent. So if the two angles are congruent, if they are equal, what's definition of congruent angles? What do you think that means?
It just means that they're equal.
That would really be that same thing we definition of congruence we did before. No difference. We would just say that they are equal measures. So we don't really change anything except take away the congruence symbol. So what's the symmetric property saying then? It's right up above. Yeah, you're just flipping it. That's what symmetric property does. Just flipping it. Thus blank by the definition of congruent angles.
That'd be fancy.
I don't know what that line is. I would have thought we were done already, but let me see.
not be fancy by saying thus, really.
We skipped all of those. Thus, oh, okay, so then we would say, then we're just going back to congruence. So again, we're using definition of congruence. Angle K is congruent to, they just wanted to say, to go back to congruence. That's, I don't know why. Yeah, I don't know why. I'll be honest. This is why proofs are weird. Like, I don't understand why we have to go through all of this to just say
Just
that
say
we can
thus.
flip the side of it. I don't, I'll be honest. I don't.
It's based
So,
on-
It's probably.
We're gonna get to other proofs that'll make more sense to try to prove something out,
It's
but
probably, they're trying
that's
to
kind of.
impress, whoever made this trying to impress their colleagues
And I will say there probably was
Yeah.
some of that, and throughout history, there were probably some people just trying to show how much they know. I don't
Trying to
understand
show
why
how
you need
much-
to do all of that.
Wasn't there a test that they like said the best way to do something is the simplest way, right?
I'm sure a lot of people have said that.
And then look at this.
I
makes
know- I
it
know
all
one
become More
thing.
complicated.
I know one thing, this is the best method. Do you know what this stands for? When you get into business, this is something you'll use in business. Always remember that.
Hiss.
Not the band, it's not the rock band. Anybody have any idea what that stands for? Remember that for the rest of your life in your
Yeah, I do.
business. And people that
Yeah.
you work with, especially managers, will appreciate that.
Okay, so the
You will never, if you don't know what it means, you'll never come up with it. No, you'll never come up with it. It's so much simpler than that. It means keep it simple, stupid.
Oh.
Don't make something more complex than it has to
I thought
be.
you said like
Just,
schematically.
Like
Yeah.
managers don't want to read through a lot of fluff, and like there's a thing actually you put in a document at the very beginning called an executive summary. You, depending on what your job is, I used to have to do them quite often. Managers don't want to read your whole paper. They don't want to see it all. They just want to know, okay, what's the problem? What's the solution? That's all I care
Then why
about.
would
And then
you-
what's it going to do for me? How is that going to benefit
Then
me?
why
That's
would you-
all they want.
School was just.
They want you to justify it so they know you've done the research. But they don't want to go through and
so
read it.
could you just like grab a whole stack of papers, write some random stuff on?
And so many jobs.
Yeah, well, again, most of what you do in school, you'll never use. I'll be the first. But what school does is you learn how to learn in school. And that's what it helps you with. And if you do the right things, it creates good habits. If you do the wrong things, then it'll create bad habits. All right, so theorem, congruent supplements.
What was your favorite job when
Um,
you were a kid? Pretty young.
The next two columns say design.
And that's-
Yeah, I know, we're not really getting to a whole lot of proofs. I don't want to do any of that stuff.
It's on 174 is for the next.
Have you told?
Let's just get to a proof and work through. Oh, man. Oh, here, I'm gonna use this. What was that?
Have you told your other classes about the kiss thing?
No, I
You should
just popped up.
You should just
today.
like, try it on the board.
I'll be honest, I don't even remember why I just wrote it up there now. I just did it. Congruent angles, is this a
That's
proof?
right.
Ah, I hate prayer. All right, we're still gonna go through this one though.
Stats that you felt.
All right, so if we know angle 1 and angle 3 are vertical angles, again, what's a vertical angle? More of these we can review and just remind you what they mean. Yeah, so right here, right? When we have two straight lines, and again, they can be super skinny like that. They could be more like this, where they are possibly right angles. If we have two straight lines, vertical angles says those are congruent with each other, and those are congruent with each other.
And you don't
That's
know if
vertical
it's a
angles.
right angle because it doesn't have the top.
And we don't know for sure that they are right
Does
angles.
it tell us? A red angle.
So now what we want to prove is if we know angle 1 and 3 are across from each other, we want to prove that that means they're congruent. That's gonna scroll. I guess it doesn't matter if I leave that there. That's fine. I'll erase it in a minute. So right now, all we know, which is visually, it's pretty simple to tell, you know that too. We know angle 1 is across from angle 3. how can we prove, let's just walk through it. What do we know? What other property did we go over earlier that we can use? There's only really one other thing that we know based on this figure, because they didn't give us a whole lot, right? They didn't give us anything except for the fact that angle 1 and angle 3 are vertical angles, they're across from each other. So what's the only thing we know in that figure? There's only one thing.
4 angles.
Well, okay, so we do know they're 4 angles, but what's the only
But you said there's something.
like proven concept we can use, not
Angle
just
1
visual?
plus angle 2 be
So this is a big one. So now that we're into angles, we're gonna add a big one. So angle addition is a big one. Little angle plus little angle is big angle. Here's your next big one. Actually, here I can fix that. Those two angles are collinear. Remember, we just went over this. If they are collinear, that
it's
really does. I hate it, so the feeling is mutual.
Should say that.
it's experience.
Ah,
Monday.
It's like more
Every day is Monday
Oh,
for it.
well, went away for a second.
You're gonna have way a lot longer than that. You kept tapping.
It's
Oh, wow, that was weird.
it's experiences Mondays.
Tapping.
Every day.
That is crazy. It will not go away. Yeah, but tapping should do it.
I think you-
There.
It opens.
Yeah, still close. Okay, that still didn't work, but fine. All right, so we know, again, this is a big one. You got to remember this when you're talking about angles. We know angle 1, or the measure of angle 1, plus the measure of angle 2 has to equal 180, right? That was that supplementary postulate that we learned. So we know that those two added up, and then we know that same thing for all of the other angles really that are on the same line. Angle 1 plus angle 4 have to equal 180. 3 plus 4 have to equal 180. 3 plus 2 has to equal 180. That's really the only thing we can get out of this figure right now, because we are proving that those angles are equal to each other, 1 and 3. So we can't use vertical angles yet. That's what they want us to prove right here, is that they're equal.
Mr. Gill, when
Congruent things.
all the angles plus each other be 360, like how
And you could say that too. All
Like
the angles
it
added together
would
would be 360. You could say that if you wanted to. That's not really a postulate
Yeah.
though, but that would be something they may ask you to prove. They may ask you to prove that all 4 angles added up equal 360.
Would
So you
it
could
not
have to
be
do
a
that.
circle?
I don't think there's a theorem for that. I think you would use the fact that these two added together are 180, these two added together are 180. Therefore, if you like substitute in or something, 180 plus 180 is 360, or something like that.
Seems
Maybe
more
there's a
work
theorem for
than
every-
just-
Yeah, I mean, maybe there's some kind of a postulate for it to say they all added to 360, but I don't know of one. All right, so because 1 and 3 are vertical angles, they are formed by, I would say, 2 lines. I'm not really, wouldn't necessarily have to be perpendicular, because this also is vertical and they're not
It's
perpendicular.
them.
So we can't say they're, I'm gonna say 2. Hey, it went away. There we go. Finally. I'm gonna say 2 lines. So angle 1 and angle 2 form a what? Angle 1 and angle 2 form a what? Corinne, what do you think? What do angle 1 and angle 2 form? So it's collinear is the word, but that's the concept you need. So that's fine. As long as you understand where we're going with it, that's fine. I think what they actually want you to write in is not a whole lot of room for it, but a collinear pair. But the reason they're asking that is because of the 180 thing.
There isn't that much room then. Would it make more sense if it was 180? Because they like,
Well, but that would,
Because sometimes
the
they can be
English
one.
behind it, a 180 pair wouldn't make sense. Like that English wouldn't make sense. That is what
Oh.
they're basically saying. I mean, I can look it up and see if that's what they put in.
on the paper, it's like the same. But for some reason, two,
Oh, it said actually it wasn't 2 lines, it was intersecting lines, not 2 lines. So if you're filling stuff in, that they actually have intersecting. Again, I'm not. 2 lines would have been fine. 2 lines would intersect. I mean, that's same
Supplementary.
in a paragraph proof, it's not like there's only one way to write a paragraph out. What's the one?
So when.
There we go.
Yeah.
So yeah, linear is the right answer for the next one. They said linear. So by the supplement theorem, angle 1 and
2.
angle
Wait,
2.
you put collinear for angle 2 and 3.
Thus.
Wait, what?
You put collinear for 2 and 3 and after insert.
Oh, you're right. I'm sorry.
Yeah.
Well, it's actually, I think it's, oh, you know what? It's not collinear pair. I think the reason why it's a smaller box, it's linear pair is the right word. Again, the angles are collinear. Well, I mean, I would have been fine with that. A collinear pair, a linear pair, I would have been fine with that. I guess maybe linear pair is
so much better.
So we know angle 1 and angle what are supplementary?
Angle 2 or supplement.
Yep, we know those. That's the two we just talked about. And then we know same thing for angle 3 and what? Is it angle 4, do you think? We could, I mean, that is true, but is that going to help us replace anything if we're using a totally different angle? And again, I'm just asking, I'll be honest, I don't know yet. Sometimes you just got to work through it. Because if I write angle 4 here, I'm not able to compare anything. Like,
Maybe you should check. Maybe it's thing.
I am going to check, but I want you guys to think about it with me first. Because I'm doing the same thing you're doing. I'm thinking through it. Think it's angle 4? All right, let's try angle 4. Let's try angle 4. We're doing this like we would do a proof right now. This is exactly what you're going to go through. What's that? Well, it definitely can't be angle 1 because we haven't proved yet that, well, those wouldn't be supplementary. Actually, angle 1 and angle 3 wouldn't be supplementary anyway. The only option is it's either 2 or 4. If angle 3 is here, either 2 or 4 is supplementary with it because those are the two that are on the same line.
It could be angle 2.
I'm thinking it's angle 2 because somehow we're going to try to bring in these and use that information together. If I'm using angle 4, that doesn't really help me with anything, I don't think. So we'll see. I mean, we'll find out. Oh, shoot. I really should type in stuff instead of writing it in.
Why?
Well, because then when I scroll, it all stays there. If I type it in, it would actually stay in the boxes. I tell you what, well, then we can't see the bottom part then. Here, we'll go back and it's hard sometimes to.
Mr. Gill, couldn't you have like, did what you did with moving that thing, but let's all.
Intersecting, see, then you can't even see the whole word. That's the problem with that.
You have all of them at once, like all the things you wrote with them, marker. Like.
Oh,
select
well,
all
yeah,
of them and then move
but they
them up.
won't move all together. You got to move them all, and if you don't write
But
them
you
all at the
selected
same
more
time.
than one. When
I don't know that I can. I think I can only do that in that other software. I don't think I can do that on the internet. I don't know. I'll try it next time. It's a good
like what
question.
you did moving your 8.
But I had to
It
do them.
allowed you
But I had to
select
do them each separately. Like I
But it
couldn't.
selected the all of them.
No, I moved them separately. I moved each because one was still out of place because I didn't move it far enough. I'll try it next time. I'll try to select them all though. You might be able to select them all. I didn't try that. So angle here. How do we put an angle symbol in? Anybody see an angle symbol?
Go to geometry.
Yeah, geometry.
There we go. See, we're learning new stuff. So angle 2 would be go in that box. So here, I really think that's going to be thus. So let's see where we're trying to go. So again, this is a paragraph proof. Sometimes jumping ahead in the proof will help you figure out a step that, like I said, when we did it the other day, we kind of went backwards to figure out one of the steps. So if I'm trying to say thus angle 1 is congruent to, yeah, that, I mean, that's kind of telling us what it would be. So angle 1 is congruent to angle 3. So I feel like we're going to have to write 2 in there because 4 is not going to do us any good. That's a brand new piece of information that does no good. If we're already finished here, it's got to be angle 2. So again, this is the way you would go through and do it. Apparently it doesn't stay on geometry. Angle 2. So now that we're saying, so here's kind of, that's fine, I can do this. So we're saying angle 1 plus angle 2 is 180. Well, we're saying, okay, well, we know angle 2 plus angle 3 is 180. So we're kind of saying, okay, well, if we know that 1 plus 2 is 180, and if we know 3 plus 2 is 180, then angle 1 and angle 3 have to be the same number. Like there's no other way to get to 180 because this is the same angle. So these two have to be the same angle. We're getting 180 both times. So that's how we would kind of work through our logic on that.
So it's angle.
No, it's the congruent symbol. Oh, man.
Oh.
Hold on.
Oh.
All right, so I'm gonna have to get rid of that apparently. There. Congruent. That's probably gonna make me delete that. There we go. So that would be kind of how you work through that process. Just again, you just got to do your best step by step. Sometimes remember, going backwards will sometimes help. So don't forget that little, not really a trick. I mean, it's a strategy, I guess you would say. All right. Any questions on that? Again,
Aren't these questions
just the
like,
more of them you do when you practice IXL, the better off you'll be. We'll try to get through these pretty fast. You can probably, even if we haven't finished all of these by 10, we'll just start doing IXL because you can always do the line segments addition and stuff. Congruent, supplements, and complements. Oh, here we go. This is what I wanted to get to. More of a traditional 2-step. All right.
4 steps though.
Actually, yeah, let's see how long.
Oh,
It is only 4 steps. So this one should, this is an example of what I would expect us to be able to do. Something that only has a couple of steps like this. Not a super, I don't think it's super challenging concepts. Both of you too. I'm gonna have to split that little connection up there. That's just non-stop. It is, but all right, so first thing is always what? When we're doing a two column proof at least. Always the statement that is given and then the reason would be given. Now we get into, I guess they told us maybe or showed us. Yeah, they showed us we had 2 right angles. So we could say kind of a weird picture, especially probably in yours. ABE is 90 degrees, DBC is 90 degrees. Yep, that's what they put. That's just definition of, that's almost given. It's kind of like the same thing as given information, putting that symbol there, but I guess they want you to state that's the definition of a right angle. Now we should be able to figure this one out. If they give us the statement, we should be able to come up with the reason. So how do we know ABD and DBE are complementary, or that DBE and EBC are complementary? Yeah, that was that complementary thing. They're kind of, it's kind of also angle addition. You could say that they both have to add up to 90. So you could almost make an argument that they have to add up to 90. You could use that complement theorem as well. I'm assuming they're using the complement theorem, but let me just make sure. Yeah, complement theorem for 3. So that would be your reason for 3. Oh, that's fine. I don't need to scroll anymore. So complement theorem. Again, if it's about 90-degree angles, complement theorem's probably a pretty good guess. If you have 90-degree angles involved and there's 2 smaller angles inside that 90-degree angle, I'd say that's a pretty good go-to. And then last, but certainly not least, let's see, we're going from A. Well, it could also, remember that, don't know if transitive, they're not really saying they're equal.
It might be either substitute.
I don't know if you can say substitution, because that would be, it would really be transitive, but they're not saying that this equals that or is congruent to that, and then this is congruent to that. So we can't really use that, I don't think. Oh yeah, that's a little bit, well, I don't even remember seeing that. That is called, boy, this is one that I don't remember seeing. We'll have to go back. It was the, wait, did I write that wrong? Yeah, it's called the congruent complements theorem. I don't remember seeing that either. So I'm going to write it down, write it in, because that's one I think you'll see on the district test. Congruent complements theorem. I'll explain it in a second how you can try to remember it. So that's the, it's the same concept as that transitive or really just substitution. So again, if you think substitution works, here's another one that if you don't see substitution listed, this would be another go-to, because again, it's not telling us these two are congruent or these two are congruent. So we can't really use substitution or the transitive property. It's telling us that they're both complementary and then we have a shared angle in there. So that would be congruent complements theorem. That's really what they were using in the problem above also.
Is it basically just combining congruency theorem and complementary?
Yeah, pretty much. I mean, it's really what they use in the other problem. That they didn't say this was a reason, because I guess it was a paragraph proof, but that's what they did in that other problem, basically.
What is a paragraph?
So that's one to make a note of, put a little asterisk by that, because you'll probably see that in the district. I would be shocked if they didn't use, they like using ones that aren't
Like using
the
one
most
thing.
basic ones, but at the same time, they're not the most obscure either. So I would say that's a pretty good one for them to throw at you on the
They like,
district test.
don't they like, things like.
All right, let's try to get through one more and then I'll just let you go in and practice the line segments. And if you want to do some of those, you can. It's another paragraph proof. Oh, it's the same exact thing we just did though. Wait, is there a picture with yours in the book?
Yeah.
I guess, is it still using that up there?
It's 170.
Given 1 and 3
It's
are
a different one.
supplementary. Yeah, I don't,
Like a staircase.
am I not seeing the picture or something? Huh,
Or zoom out.
it's weird.
Might be zoomed in too much. And it's just not.
Yeah,
giving you the size.
I don't have the, oh, you know what? It might be to the right. You might be right. Might be correct.
Because there's.
Well, no, it's not letting me zoom or not letting me scroll left or right or anything. That's weird. I can't. It won't let me. I can't.
Forward.
Yeah, I can't zoom out. There's not letting me do anything.
Go to the next page.
Shouldn't be on another page though, because the pages match up. So yeah, it can't be on the next page.
Hey,
It's got to be on 174.
your screen
Because
is.
these pages should always match up with your book, and I see it's on your book page. So again, I'll just give you the answers if you want to write them in for that check real quick. The first one is supplementary. The second one is supplement theorem. So that would be just, you know, that they're a linear pair and they add up to 180. And then the last one is the kind of like what we just used there, the congruent supplements theorem. So if one angle plus another angle, so this kind of thing. So if angle 1,
What about the blank angle?
I think I said that was, wait, blank angle. Where you, so the, again, there's only, oh, angle 2, sorry, yeah, angle 2. So if angle 1 plus angle 2 is 180, I don't even know if this goes for your problem or not. And then angle 2 plus angle 3 is 180. Then we can say angle 1 plus angle 3 is 180. That's what the supplements, congruent supplements theorem would be. If these two add up to 180, this is actually what we did in the other proof up above, but they didn't really tell us that reason. If these two add up to 180 and these two add up to 180, well, these two have to be the same number. That's the only way we could get 180 both times. So that's the congruent supplements theorem. Kind of like the same thing we just did with the congruence complement theorem. All right, let's go ahead, get your technology out. Phone, laptop, whatever you